In GAMS, the object function cannot be minimized or maximized directly. This is because it is a function. In the object function, there are one or several variables. If we know the values of these variables, then we can calculate the value of the object function. This means the value of the object function also varies with the values of the variables. So we can define a free variable with 0 dimension and let it be equal to the value of the object function. Then such free variable can be minimized or maximized. We can use the keyword variable or variables to define such free variable. As we let a free variable to be equal to the object function, then we convert the object function into a constraint. By doing this, we can implement into GAMS using the keyword equation or equations. For instance, this is the object function. Then we can use a free variable with 0 dimension z and let it to be equal to the value of this object function. Then we can implement by using the keyword equations or equation. This variable can be defined by using the keyword variable. Here I want to emphasize the variable to be equal to the object function should be a free variable with 0 dimension. This is very important. If we define this variable as other types of variables, such as positive variables or negative variables, then GAMS will give you some error message. Let's go back to GAMS and implement the object function. In the transportation example, the objective is to minimize the transportation cost. We first need to define a free variable to be equal to the object function. So we should use a keyword variable or variables to declare and define this variable as a free variable. We give a name z to this free variable. You can also provide another name. After that, we convert the object function into a constraint. Then we declare this constraint using the keyword equations. So we add here, we give the name of this constraint. Because this constraint represents the objective, so we give the name obj. And then we also provide text to describe this constraint. The objective function. After that, we need to define this constraint. It starts with the name of this constraint, obj, 2 dots, and the expression on the left-hand side, z. The equation type is equal, so we use the equal sign. And then write the expression on the right-hand side, the total transportation cost. We write F times distance Seattle Topeka times the amount that are shipped from Seattle to Topeka plus the transportation cost from Seattle to Chicago. We can add other transportation costs. If we cannot finish in one line, or if we don't want to put all of them in one line, then we can use another line to put. Then we finish implementation of the object function into GAMS. Next, we should define the model. This is the syntax to define a model. It starts with the keyword model or models. Then is model name. The model name is specified by us. Then is text. The text is used to describe the meaning of this model. It is optional. After that are two slashes. Between these two slashes, we can specify which equations should be included in this model. If we want to include all equations we defined, then we can simply use the word all. If we want to include some of the defined equations, then we just put the equation name that we want to include in the model in these two slashes. Different equation names are separated by using comma. If we finish this statement, then we have to add semicolon. If we still want to use this statement to define another model, then we should remove this semicolon and then continue to provide model name and the text and two slashes. Between these two slashes, we can specify the equations we want to include in this model. For instance, if we define a model transport, we use the keyword model and then the name is transport. Here, the word all is used. That means all equations defined are included in this model. If there are 3 equations in total in the model transport, we can also list all equation names between these two slashes. This is equivalent to using all between these two slashes. We can also specify the equations we want to include in the model. For instance, if there are 3 equations named cost, supply, demand, if we only want to include the equations cost and supply, then we provide the name cost and supply in these two slashes. By doing this, demand equations are not included in the model transport. Similarly, if we only want to include the equation cost and demand, then we can put their name in these two slashes. That means we don't include the supply equation in this model transport. Here is one example to show you how to use one model statement to define several models. If you define these three models in one line, then you should use comma to separate them. After we define the statement, don't forget to add semicolon. Okay, now let's go back to GAMS and define the model for the transportation example. It starts with the keyword model. Then we need to specify the name of the model. Here we use transportation as the name of this model. Then we need to add some text to describe the meaning of this model. Let's say transportation example. Then two slashes. Within these two slashes, we can specify equations that we want to include in this model. Because we want to include all equations in the model, so we use all. And then we finish this statement, we have to add semicolon. We can also provide all equation names in the two slashes. These names should be separated by comma. Which way is used is up to you. Let's change back to all. Let's use all. Then we finish the definition of the model. Next, we should use solve statement to solve the model. This is the syntax for solve statement. It begins with the keyword solve, and then model name. The model name is defined in the model statement. That means the model statement should be placed before this solve statement. After that is using this is also the keyword. This is also a keyword. After that is model type. In GAMS, there are several model types, including linear programming model, nonlinear programming model, mixed integer linear programming model, and mixed integer nonlinear programming model. If the model is a linear programming model, then LP is used in the solve statement to denote the model type. If your model is nonlinear programming model, then NLP is used in the solve statement to denote the model type. Similarly, if your model is a mixed integer linear programming model, then MIP should be used in the solve statement. If the model is a mixed integer nonlinear programming model, then MINLP, this word should be used in the solve statement to denote the model type. After that is to specify direction of optimization. The optimization is minimize or maximize. If minimize, then you should write minimizing. If maximize, then you should write maximizing. After that is variable name. This variable name is a free variable that is used to denote the value of the object function. You can also put using model type after maximizing or minimizing variable name. Both of them are the same. This is one example to show you how to use solve statement to solve a model. Okay, let's go back to GAMS and use this solve statement to solve the model we defined. It begins with the keyword solve, S-O-L-V-E, solve. Following that is the model name. In the model statement, we define the model name as transportation. Then the keyword using. The model is linear programming model, so we use LP. In lectures, we will introduce linear programming model, nonlinear programming model, mixed integer linear programming model, and mixed integer nonlinear programming model in detail, so you don't need to worry. Following the model type is the direction of optimization. For this example, we want to minimize total transportation cost, so we should use minimizing. And then is a variable name. The variable name should be the free variable we defined to denote the value of the object function. Here we define it as z, so we should write z here. After we finish this statement, we should add semicolon. Then we finish the solve statement. After solving, it is better to use display statement to display the optimization results. This is a syntax for a display statement. It begins with the keyword display. Following that is an identifier. This identifier can be the name of a set, a scalar, or a parameter. This identifier can also be the name of a variable, an equation, a model, and so on. We can also use this display statement to display some text. This text should be single-quoted or double-quoted, like this. If we finish, then we should use semicolon. We can also display another identifier in the same statement. Then we can continue to display another identifier and some other quoted text. Different identifiers in the same statement should be separated by using a comma. For instance, if we want to display the value of a set I and a scalar A, then we can write like this, starting from the keyword display, and then the name of the set I and the name of the scalar A. They are separated by using a comma. After finish, then we should use semicolon. If we use display statement to display the value of a variable, an equation, or a model, and so on, we have to add suffix. For instance, if we want to display a value of a variable, then we should write like this, starting from the keyword display, and then the name of the variable, and then dot suffix. Don't forget the suffix for variables, equations, or a model. There are several suffixes available in GAMS. We often use these four suffixes. .lo means lower bound. .l means level value, actual value. .ub upper bound. .fx means a fixed value for the variable. For instance, if we want to display the values of variable x and variable z, then we can write like this, starting from the keyword display, and then the name of the variable x.l, the name of the variable z.l. If we also want to display the lower and upper bound of the variable x, then we can write x.lo and x.up. We should use commas to separate them in one statement. The display of an equation or a model is very similar to the display of a variable. For instance, if we want to display the value of an equation, eq1, the name of the equation, then we can write display, and then equation name, equation1 dot l. Then we finish. We need to add a semicolon. Then we can use this one to display the value of this equation 1. Okay, let's go back to GAMS and use this display statement to display the optimization results. The display statement begins with the keyword display. And then an identifier, because we want to display the optimization results. So the identifier should be the name of the variables. We first display the value of the variable, denoting the amount of products that are shipped from Seattle to Topeka. X Seattle Topeka. When we display the values of the variable, we should add suffix. The suffix for the value is .l. We also display the values of other variables in the same statement, so we should put comma, and then we can do the same for other variables to display their values. When we display the text, we should use single quotation mark or double quotation mark. For instance, if we want to display the text or a transportation example, then we can write like this, starting from the keyword display, and then we can use double quotation mark, and then we put the text, a transportation example. And then if we finish, then we can put semicolon. By doing this, we finish the display statement. Now we finish the entire GAMS code for the transportation example. We can run GAMS to get the optimal solution. Let's do it. We click this button, Run. And then you can see from here, there are several errors. So we need to fix these errors. When we fix errors, we should always start from the first error. This is because some other errors may be caused because of the first error. So let's see the first error. The first error is here. Mention unknown symbol. So let's go to the place where the error takes place. It means this symbol is unknown, is not declared. Because we already declared this one, we need to check if this symbol matches the symbol we declared. We need to check very carefully. Let's see. The mistake is that we add additional t. So we need to remove this t. And then we need to save the file. And then after we fix the first error, we need to rerun. And then you can see all other errors disappeared. This is because all other errors are caused due to the first error. This is why we need to always fix the first error. And then we can go to the list file to see the optimization results. So first, we can see the model statistics. So here we have the model statistics. We have 6 equations and 7 variables. So then we can see the solve summary. As we mentioned, from the solve summary, we can see the model's status. Because the number is 1 and it's optimal, that means we get the optimal solution. From here, we also can see the objective value. So this is optimal value for the object function. And then we can see which solver is used. Here, simplex solver is used. This solver is usually used to solve linear programming, mixed integer linear programming problem. Next, we want to see the optimal solutions for all variables. So here we can see from solve variable, solve var. Under solve var, we can see the solution, the optimal solution for each variable. For instance, the optimal value for z, because z is a free variable denoting the value of the object function. So this value is 153,675. Also, we can see the optimal value for other variables. For example, we can see X Seattle Topeka. This variable is used to denoting the amount of products that are shipped from Seattle to Topeka. But you can see from here, the full name of this variable is not displayed. This is because the maximum length of the variables that can be displayed is 9, and the name of the variables we provide exceeds 9. If we want to see the full name of the variables, then we can reduce the length of the variables, or we can see from the display statement. So here we have the full name for each variable. We also can see their values. For instance, we can see X Seattle Topeka, this is 0, and X Seattle Chicago, the optimal value for this variable is 300. If we have long name for variables, then we can display the full name of the variables using the display statement. In the GAMS code, we also use display statement to display a text, a transportation example. So the display results is here, a transportation example. Okay, we finished this GAMS tutorial. Hope you understand how to implement the mathematical formulation into GAMS, and then use GAMS to get the optimal solution. Thank you very much. See you then.